Welcome to my presentation about watermelons, which is Citrullus lanitus and food security. My name is Sipho Mlonyeni. My student number is 3745916, and this is ESS 221. My assignment or presentation will have introduction, the methods, research objectives, watermelons in South Africa, interpretations, and references. The crop that I will be speaking about in this presentation, the scientific name is Citrullus lanitus, and the common names which is used in our everyday life, it's watermelons, and the family name is Cucurbitaceae. This presentation will be focusing on areas where the most watermelons are produced and in some areas in South Africa. The largest producer of watermelons is China, followed by Turkey, and Iran is the third largest producer. It will also include maps and grids as well as the background and information about watermelons. Watermelons originate in West Africa and they are firm, strong, usually 3 meters long, and male and female plants occur on the same plant. They come in two varieties, which is watermelons and citron melon. The growth is in tropical and subtropical areas, which means that they usually grow in hot and where there is mostly heat. In order for the watermelon to grow efficiently, temperatures need to be greater than 25 degrees or 77 Fahrenheit to grow successfully. Suffer from plant disease, powdery mildew, and mosaic virus. It contains 91% water and 6% sugar. The amino acid citrulline is produced in watermelon rind. The ideal environment for watermelons to grow, they love the warm weather. It is a frost-fender annual plant that produces large juicy fruits late in summer. They are usually in round or oblong shape. Watermelon love the sun and the heat and need a long and warm growing season of at least 70 to 85 days to produce sweet fruit. They need to grow in a warm area to develop completely. They grow best in fertile, well-draining, sandy soils. They need a lot of space in order for them to grow successfully. Methods that I will be using is DIVA GIS. I will also collect species data. I will also sort and clean data, apply data, and the model. The objectives of this presentation is which space or environment is more suitable to grow watermelons? Where do watermelons grow? Will the spacing be sufficient for its growth? What are the advantages and disadvantages for growing watermelons? The ecological niche models is used to define the descendant position of a species in an ecosystem. It also describes how a species lives and interacts with other organisms. It is also roles that species play in the environment. Climate change is a change in global or regional climate patterns, in particular a change apparent from the mid to the late 20th century onwards and attributed largely to the increased levels of atmospheric carbon dioxide produced by the use of fossil fuels. This has had a catastrophic effect on the Earth's climate system, affecting it mostly adverse ways. The results to showcase the presentation, I will be using BioClim, domain, limiting factors, and EcoCrop. This is the current global distribution of watermelons, and this grid or map showcases all the different areas. So the gray represents the not suited, the green very marginal, the light green is marginal, the yellow is suitable, orange represents very suitable, and the red represents excellent. So on the graph, most of the areas are covered by the green, which is very marginal. So in those areas which are represented by very marginal, it means that those areas are not excellent or suited for watermelons to be planted in those areas. And the gray areas means that no watermelons are suited to be in those areas. So the yellow part represents the suitable, and there's a little red part that represents excellent. So only in that part is where watermelons are suited to be grown so that they can be successfully produced. In the future global distributions of watermelons, most of the areas are covered in the green, which is very marginal, and there's a little part in the area which is suitable and it's covered in yellow, and some of the parts has excellent, which is in red, which means that is where watermelons are suited to be grown in successfully. So the areas that are covered in green is very marginal, which also means that it's not ideally to grow watermelons in that areas. The current eco-crop of watermelons. Eco-crop helps to identify plant species for given environment and uses. It is also an information contribution to land use planning. The app that was used to complete this current eco-crop of watermelons was the DIVA. It uses temperatures and precipitation variables to analyze how suited the crop is to a particular geographic location. Red is in the most of the tropical regions and the majority color is red, meaning it is excellent and suitable in the area. The future eco-crop of watermelons also mostly has red, which means that the red is in most of the tropical regions and the majority color is red, meaning it is also excellent and suitable in the area. This is the current global domain of watermelon. As you can see, it's covered in mostly green and light green, and there's some areas which has yellow and red. So in the areas where you see the white, that means that there is no data in those areas. In the future global domain of watermelons, there isn't much different from the current one because most of the areas are still covered in the darkish green and the light greenish, and some areas have yellow and red, and there's also some parts which has white, and that represents no data. This is a pie chart which represents the production of watermelons in different countries, and this is the top 10 countries in the world. China is the largest producer of watermelons because the weather there is favorable for its cultivation, and it is produced with excellent quality because of its special type of climate. Turkey is the second largest producer of watermelons, and they also host a watermelon festival annually. Iran is the third largest producer because the energy production is direct and indirect, and the farmers use renewable and non-renewable energy. For the interpretations, I will be using a plot analysis, and the first one I will be starting with is threats. The watermelon is full of vitamins such as vitamin A, B6, and C. Watermelon is also packed with vitamins, which is lycopene and amino acids. If the fruit is eaten excessively, it may cause problems as too much vitamin C, which is found in the watermelon, may cause symptoms such as diarrhea and gastro. Potassium is also found in the fruit, and too much of it might lead to complications such as hyperkalemia, which causes an abnormal heart rhythm and can be dangerous. Overall, watermelon can be consumed safely with little risk. The second one I will be speaking about is limitations. The limitations of watermelons is that it is mostly grown in summer weather because it needs the heat to grow effectively. Now in rainy and winter days, it becomes a challenge to the farmers because now the environment is not conducive for the crop. The third one is potentials. Watermelon is a crop or species that shows a lot of potential. Since the climate is changing and hotter days are longer, that is good for growing the watermelon because it grows mostly in warm and hot regions around the world. Even in South Africa, most places where you would find watermelons is in Mpumalanga, Limpopo, and Northwest, as well as some areas in the Eastern Cape, and most of those areas are hot most of the time. If you would like to get more information about where I got the information for my presentation, you can go through these references. I hope you enjoyed the presentation. Thank you for watching. Bye.